Today's date is the 13th of July 2026. The time now is 3:04 p.m. Let's get into it. So this is here. Here the behavior model here. Using basic inputs, behavior, time, uh, S at time, current world states, current input, observation, memory or preservation, goals or action, rules of learning policies. Basically, some saying. So you have to start this hubs of life, hub of focus. Yeah. So today's date is so how to model behavior. Behavior has a state and an action. So this is basically not related to anything. But yes, malfunction. So here I've got how to model behavior. I've got uh these things here. Go ChatGPT open. Behavior at time. Behavior equals B for behavior sub T of the time equals a function S of time of control states I of input or observation, M for memory or previous events, G for goals, R for rules or learn policy. The change behavior environment produce a new state. Uh, S sub T plus one equals T, where T is a function of S, B, and E. For example, observe, interpret, decide, act, measure, results, object memory. For video call, video will be this is silent. Look away. This is thinking hard, struggling, uncomfortable. This is basically the UAI referring to. The prologue goes on true observations, absolute truth. It's not proof, engagement. The important part is not to treat an observation as absolute truth. Looking away is not to prove the game image. Your model should retain uncertainty. Probability of this engage given looking away equals 3.35. A final state machine is one of the easiest ways to implement behavior. Ideally, listening, reasoning, speaking the same. Ideally, user speaks, listen, speech ends, using response prepared, speaking interruption detected. The same. So this is the model of behavior. A rich Bayesian model will be for uncertain behavior, maintain competitive affiliation. A probability of Hi given O, P is probability of O given H some interval. PH is basically the base theorem. Yes. Divided by summation of P given O such as H J T H J. This is base theorem. But this is a yeah. Uh, okay. Then I asked the AI system. Then what did I ask the ChatGPT? I asked the AI system. Observation action. Yes, action. A is what I was looking for. Equals pi. Believe goes constraint. where your introduction will be a hybrid. Was you know in C. Okay, how to model undefined behavior in C. So this is basically on how to model undefined behavior in C. In C, undefined behavior should not be modeled as a random behavior. It means the C standard places no requirement on what after invalid operation. Useful formalization of the model is this. Uh, program start T equals T program state. If operation is defined, program uh, the meet. This is join. No, this is a meet. If undefined behavior occurs. Uh, Here is the program left abstract machine. Let type def enum. Uh, uh, Type of enum. Execution okay. Execution defined. Execution status. Type of struct. Int value. Uh, Execution status. Results. So this is the idea of undefined behavior. So I'm trying to undefine behavior in C. Modeling undefined behavior as non-significant anything. For reason, UB can represent every possible outcome. UB undefined behavior state equals sigma, where sigma is the set of all possible program states. Okay, this means that UB, the model, cannot safely conclude anything before UB, after UB. Okay, now I'm learning something from my own AI systems. The mathematical accurate uh, but it's too broad for debugging. Model you'd be using Poisson values. Compiler intermediary presentation as a concept like a Poisson value. So what's a Poisson value? Oh, this thing bit me so badly. I got 2 bytes now. 3 bytes. Anyway, compiler interpretation often is content for Poisson value. So I'm basically what we're saying is that I'm trying to model undefined behavior in C, but I'm trying to get to the read the article so I can save to my log. Valid value. Value. Overflowing operation, poison. Operator using poison. Poison spirits. Overflowing operator. Overflowing operation. Like a battlefield or like a stream of bytes overflowing in a array. Poison. This is the poison. Overflowing using poison. Poison spreads. Observation using poison. Observables. This is observer and consumer pattern. Uh, Undefined behavior. You spoken like this. Abstract int. Oh, it casted 0 and 1. So int value 3 equals value 5 because 1. There's no out of band access. Common EB categories out of band because there's no rotation uh, for that model. Read array a so 0 less than I, that's an array rate. No point. Okay. So this is not my point. Just to get to the end, Namji. It's your people that are sick. Thank God it's your people that are sick. I'm not sick. I'm not your person. The level P equals memory P is valid. Otherwise, meet. Otherwise, and P equals Malachite has a P. Free P. Free the type and value because you're freeing the type and value, and you cannot reuse it because you have to reallocate. You have to reset it. With Malachite. So it's a this is a pointer P equals setting of use after free. You cannot use it. You have to set it, and that's the problem. You just have to set the type, then the value, then use after. So pointer and carry location type. Pointer address location alive bound. This is a good way to think of pointers. Pointer address alive bound. Alive any bound. The only certain states. This is shift. So shift Y type. A practice using an abstract state machine model to define a memory variable registered UB flag. UB is not implementation defined behavior. They're different. Undefined behavior, no requirements. Oh, so it's literally implementation defined behavior. Compiler must choose and document an outcome. Unspecified behavior. This is what I'm looking for. Special permission and compiler must need not to document your one. So this is what I'm trying to debug. This is a defined behavior required by standard evaluation. So this is looking. So this is the four categories of it. Undefined behavior, implementing defined behavior, uh, unspecified behavior. This is undefined behavior. This is undefined. So this is basically defined behavior. Specific permitted outcome. Several permitted outcomes. Defined behavior. So this is this one. Unspecified behavior on the undefined behavior, which is a you following the kind of you be looking for. A solid model therefore uses four result cases. Behavior defined, behavior unspecified, very important to define, behavior class. Okay, yes. For this system application, I'll use yes, I will use a UB model to terminate the state verification. So okay, so basically this is what I'm saying. I implementing a specification for C assembly. UB is equal to the Bruno result. UB is not equal to 70 degree. See, undefined known, unknown but permitted defined yes. So I'm gonna buy a house in Nigeria. I have to go buy a house to leave this country. Nigeria is hard. Nigeria, it's not hard. Stop telling me it's hard in my head. You're sick people. Grade build active, degrade build break new. You cannot keep me in this country. I'm not your people. Okay. Respect every house. Basically, this is what I'm saying. I implemented a specification for C assembly malfunctions, such as any kind of hardware or on-the-fly malfunction, non-technically create, destroy, build, repair as a hardware component specification. Now, this was actually doing. So, I am what's actually doing is I'm implementing a specification for C and assembly malfunctions such that they will such that we have any kind of hardware on the fly, basically on the fly is why it's executing malfunction or why it's doing operation. Like when you have latex and you have the installer package on the fly whilst your latex is compiling, your latex is compiling, your document is compiling. So I'm implementing a specification for C and assembly malfunction such that we have any kind of hardware on the fly malfunction. Nanotechnology creates, build, destroy, renew, repair, and hardware component specification for MUKO OS. So, in layman's terms, this means that our hardware has a specification to repair itself. The computer can repair itself. And that's a cool concept, actually, because it recognizes components are damaged and can try to build maybe you can build something that's moving drones or but just for hardware it should be able to build it for hardware. So because I'm building MUKO OS, the digital computer, MUKO M for Mike, M for Mike, Q for Umbrella, K for Kilo, O for Oscar, which is gonna be the hardware specification. But this is the only thing I'm building, just experimenting. I'm experimenting with all this stuff, but so this is what I'm saying. It's one of the projects I'm gonna work on. Because not necessarily is really there. Create, build, activate, degrade, braid, break, renew, repair. Will destroy irreversible unless the component is destroyed from the new location. So this is the code that ChatGPT generated. Yes, this is the code. For example, basically the motherboard for MMUKO OS. So the motherboard for MMUKO OS is gonna be silicon, but it's gonna be nanotechnology. You're gonna have nanotechnology. So if I can put this to the problem statement for MMUKO OS, phrase this in a markdown document specification for GitHub. I'm gonna put it in down because this is a state of computers. Create, build, create, break, create or destroy. But you eliminate destroying the state of computer. Um, represents how the component H T state the great fault repair rules. It can be like a software, So this is the cool part. Malfunction semantics. Use M equals location, severity, duration, confidence, and recoverability. Okay. But mm, this level is track temporal voltage, instability, permitted storage damage, corrupted memory, broken technology, incorrect instruction execution, ionic physical damage. Define the hardware solution as gamma HOE implies H prime. Where H prime? What is H prime here? The prime. I don't know what H prime stands for. Oh, this is state of the okay. It's like it's an integral. So H is current component state. O is requesting for equation. E is environment. H is resulting. Data abstract. I don't like the West. I don't care about the UK. They're useless people. Data absent create equals creative. Uh, uh, Creating and verifying. Built broken. Location is failed. Uh, Gamma broken repair equals repair. Gamma repair and verify equals active broken. This is a great state machine. But it's basically using franking functions. So this is like a similar instruction conceptually. With our plan, validate, isolate, execute, verify, commit. If we're going to go rollback before time. So this is what I'm saying. This is the code. Let me look at the type def enum, hateful transaction state. The component that does this would be cool. Well, I can use it to build drones. I can use it to build uh things that are that are basically looking at lattice, like that's the information, like uh, no, I'm keep saying lattice, but I'm saying that is a group of this doesn't just mean groups. But I'm trying to work on ordered groups. I'm trying to work on shape geometry. Things that join up components that break apart and put themselves back together. I'm saying by themselves automatically. Um, the prime on my J. It may be it's not it's impossible. It's like kind of how to query or how this works and all. We started with the concept of modeling behavior, and behavior now becomes something more than getting components to build themselves, repair themselves, renew themselves. And yes, no, maybe confidence of data safe verification of H equals yes, no, maybe. This is just Byzantine fault tolerance in in physical. Uh, okay. Oh no. Oh, mm, Byzantine fault tolerance for hardware. My upset is down, Namdi. Yeah, it's still writing. So that's what I'm saying. It's Byzantine fault tolerance. So uh, come on. I want to go home. I want to go home. Tell me I'm sick. Okay. Mm, yeah, it comes in. Okay, so literally just trying to work with this model here. You know what? Let's watch it again. So this yeah, so this is like a museum Byzantine hardware of full tolerance distribution. Okay, so let's look at this document. Let's see. Thank you for watching this video, guys. Thank you for watching this video. So it's called MUKO Byzantine hardware fault tolerance specification.